this is about a bungee jump. At the top, the GP is 24 kilojoules. At the bottom is 0. So at the halfway mark, it should be exactly 12 kilojoules. How about the elastic potential energy? It starts off 0 at the top because the rope is still unstretched. Is maximum at the bottom, 24 kilojoules, because that's where the rope is stretched the most. So at the halfway mark, do you think the EPE can be 12 kilojoules? Cannot be, right? Because elastic potential energy does not increase linearly with extension. It increases quadratically. The formula is half k x squared. X is the extension. So let's first assume that the rope becomes stretched the moment the bungee jumper jumps off. So our elastic potential will start to rise immediately after you have jumped off. So if at the end I have 24 kilojoules of elastic potential energy, then at the halfway mark it cannot be 12. In fact, it should be just 24 divided by 4. So this point here should be just 6 kilojoules. Because at the bottom, the extension should be double the extension when it's at the halfway mark. So if you double the extension, the EPE should be multiplied by 4 times. So if at the end you have 24 kilojoules here, then at here it should be 24 divided by 4, which is 6 kilojoules. In fact, it could be worse than this, because the rope becomes stretched only sometime after you have jumped off. So supposing the rope starts to become stretched only at here, and that means this rope has a larger spring constant. So at the end, you still have 24 kilojoules. Then you realize that at the halfway mark, it will not even have 6 kilojoules. It will be way less, because now this extension is actually like 3 times the extension when it's at the halfway mark. So the EPE here should be 24 divided by 3 squared. 24 divided by 9. So the conclusion is, we don't actually know exactly what is the elastic potential energy at the halfway mark, but it has to be lower than 6 kilojoules. And with this criteria, you are able to come to the correct option. Alright, that's all I have to say. Ta-ta!